Hello students, and welcome to this lesson on cube roots, or in other words, the inverse of cubic functions. Our objective today is that we will graph transformations of the cube root function using our journal notes. Alright, so first let's define what the cube root function is. So previously we have seen that the function x squared and the function square root of x are themselves inverses. And what does it mean to be an inverse? Well, inverses are those functions which cancel the effect of the other. So we see that when we take a square root of an x squared, then all we'll get out is an x. And the same thing will occur the other way around. So if I take square root x and I square it, then I will also just get x. So we're trying to find a similar function which will perform the same action on x cubed. So our function, the way that we will write it, is going to be y is equal to, we use that same square root notation, but now we use a little 3 up here. And that 3 tells us that this is a cube root and not a square root. So our function will be y is equal to the cube root of x. So if I were to take x cubed and take the cube root of it, all I would get is x. And then the same thing will occur if I take the cube root of x and I cube it. So the cube root and the cube function will cancel each other out. Now, another cool thing that we know about the cube root function is that all of its points are just reflections of the original function, right, of that x cubed. So let's go ahead and figure out what our parent function will be for cube root. So whenever we're looking for the cube root, we're asking what number will multiply it by itself 3 times in a row to give me x. So what we're going to start with is our original parent function of our cubic functions. Now if you look back in your notes, you'll see that for each input you get a certain output. So for -2, our output had been -8. Well, the cube root is just going to be the inverse of the cubic function. So now my input, my x value, and my y values here, so my input now is going to be -8, and my output is now -2. So -2 times -2 times -2 will give me -8. So that's the answer to the question, what is the cube root of -8? All right, next we take -1, and the cube root of -1 is also going to be -1. Then we go 0, the cube root of 0 is 0, and then the cube root of 1 is 1, and the cube root of 8 will be 2. So now we have these nice pairs of values that we have. So we start at 0, 0, and then we'll go to 1, 1. We'll also write at -1, -1, and then we go all the way to 1, 2, 3, 4. Our input is 8, 1, 2, 3, 4, 8, and then up 2. And then the same thing in this direction, we go back 8, and then down 2. So those will be my 5 points. And remember, this is a nice, smooth, continuous curve because you all have all of these in-between points that are occurring. All right, so that's what my parent function is going to look like. My domain is going to be all real numbers, and my range will also be all real numbers. Then I have this center point, and my center point here is going to be 0, 0. So let's go ahead and graph some of these functions. So now we're going to be transforming our parent function. Alright, so as per usual, we have our transformation form up here, and I realize that I made a little mistake, so let me correct that. Alright, so we have our transformation form up here at the top. So you notice this looks exactly like our transformation form that we've used before. So we have f of x is equal to plus or minus. That's going to control my reflection. And then I have A. A is going to control my stretch or compression vertically. Then I have my H, right? I've got my H in here, and that's going to control left and right. and then I have my k, and k is going to control up and down. All right, so let's see what these transformations will look like. All right, so I have a -1 in here. That means that h is positive, so I'm going to move to the right 1. So I'm just going to take my parent function and move all of the points. See, I've got my parent function here. I'm going to graph those in red, and then I'll graph the new one in blue. So those are my original points, and then I'm just going to shift them 1 to the right, because that's my transformation that's going on in here. So all of my points got shifted 1 to the right, and I follow the same general shape as my original function. All right, there we go. And my inflection point, or my center point, is now going to be at 1, 0. So that's the only thing that really changed out of this. We kept the same shape, it just moved over, and now my inflection point, or my center point, is now at 1, 0. All right, and then we can do the same thing here. Now I'm just going to assume, here's what I'm going to do now. I'm going to draw that original center point, but I'm going to shift that, and then everything else will follow it. All right, so this is going to shift up 3, so 1, 2, 3. All right, and we go to the right 1 and up 1, and then we go 1, 2, 3, 4, 5, 6, 7, 8, and up 2. And then the same thing is going to happen here. We go to the left 1, down 1, and then to the left 1, 2, 3, 4, 5, 6, 7, 8, and then down 2 as well. All right, so my new function here is just shifted up 3. So it maintains the same shape, it's just shifted up 3. And my new center point is now going to be 0, 3. All right, now let's do a little bit more complicated functions. So we have, it looks like 3 more functions for us to do. Let me just write this in here. So we have 2 cube root of x minus 2. Okay, so let's go ahead and do this first function up here. So 2 times the cube root of x. All right, so remember, all we're doing is we're taking the cube root of x and we're multiplying all of our outputs by 2. So I input -1, sorry, I still input 0, 0, and that'll stay as 0, 0 because 0 times 2 will give me 0. Then I go to 1, 1. Now, normally I input 1, I get out 1, but I'm multiplying my outputs by 2, so this becomes 1, 2. This is what's going on over here. Let me just write a little table. So we have our x, we have our cube root x, and now we have 2 cube root of x. All right, so I'm taking each of these inputs and I'm putting them into the cube root of x, and then I'm multiplying those by 2. So this becomes -2, this is -1, 0, 1, and 2. And then we're going to multiply each of these values, right, because that matches that, by this 2. So 2 times -2, that gives me -4, -2, 0, 2, and 4. So these are going to be my 4 outputs that I will graph at these inputs. All right, so I've already graphed 1, 2. Then I need to graph 8, 4. All right, so that's going to be our point there, and let me actually do that in red. And then the same thing is going to occur on the other side. So we have -1, -2, then 1, 2, 3, 4, 5, 6, 7, 8, down 4. 1, 2, 3, 4. All right, and so what we see is that our function is just a little bit stretched out, right? Because this is a vertical stretch, so we stretched it towards the vertical directions. All right, so now let's see what a reflection would look like. So a reflection just means that we're going to take our points, right, and they reflect across that x-axis. So let's go ahead and do that. So these are our new points. So +1 because it became +1, -1, and then 8, down 2, and then over 8, and up 2. All right, and that's going to be our reflection. And then finally, let's do this last one. So we're going to go down 2, and then we're also going to stretch. So I'll take my center point, and I'll take it down 2. All right, so my 0, 0 became 0, negative 2, and then now I want to stretch it. So I'm actually just going to follow my map from earlier. So if I've already know what my stretch is going to look like, then I can just follow that same map. So I'm going to go to the right 1, up 2, and then I'm going to go to the right 8, and up 4, and then to the left 1, down 2, and then to the left 8, and down 4. All right, and then we'll just graph our points here, or I mean rather connect them in this nice continuous line, right? Because we're connecting all of the points that are still there that we just don't see. All right, and then what are our inflection points? Well, our inflection points are just those center points. So our inflection points are going to be those central points where we change our directions. So this is going to be 0, 0. This one will also be 0, 0. And then this one, the last one, will be at 0, negative 2. All right, so your assignment today is that you're going to complete a reflection over the notes, so tell me what you learned today, and then also start on the cube root graphing worksheet. There's a front and a back to it, so make sure that you do both sides. When you're done with that, that will be your assignment for the day. Make sure that you've also turned in all previous assignments, and let me know if you have any questions. Thank you and have a wonderful day.